All right, so leveraging OpenStack at scale, how Comcast Elastic Cloud drives innovation velocity. You should really read also how it doesn't drive innovation velocity. This is going to be a talk about some of the benefits that Comcast has seen by deploying OpenStack since the S6 release, and some of the challenges that we're undergoing today. I'll just stand here. So we're Comcast. If you haven't heard of us, we're Comcast and NBC Universal. We're cable, internet, voice, and home. We also, because of the NBC Universal acquisition, are a number of cable networks, a number of film studios, a bunch of broadcast television, and a couple of theme parks here and there sprinkled around. So this is kind of a snapshot of where we are today with OpenStack. We have more than a petabyte of memory and more than 1 million vCPUs. We have multi-petabytes of Ceph and block storage, multi-terabyte SSDs, and we're deployed across 34 different regions in national and regional data centers. And today, we're actually still on the Icehouse release with a couple of new regions coming up in Mitaka, since there's no upgrade path between Icehouse and Mitaka. We do contribute to the community. As of yesterday, when I was checking Stackalytics, we are now up to 95,000 lines of code with 1,200 commits. We are core in a number of different projects. One of the big ones is OSA and Neutron. And since the Vancouver Kilo Summit, we've doubled our upstream contributions, so we're pretty proud of that. So, the idea when we first got started was, OpenStack's pretty complicated, but we wanted to build a pretty general purpose cloud to kind of meet some of our critical services. So X1, if you're not familiar with, is our kind of new next generation set-top box, a different kind of experience for watching TV, and I'll talk a little bit more about it. So really, we built this platform to try to meet as many different workloads as possible while trying to reduce the complexity of OpenStack. So we tried to do that by not having a ton of different SKUs for hardware and not having a whole bunch of different storage options inside of OpenStack. And we've been pretty successful. So Xfinity X1 is really a dynamic and a revolutionary way to really experience television. The remote control has a voice function where you can say things like, I want to watch, Band of Brothers, and it's going to go out and find Band of Brothers for you. Or it can, during the Olympics, during the Rio Olympics, you could have just asked for gold medal ceremonies, and it'll take you to any active gold medal ceremony. So it's a pretty powerful tool. And I'm also pretty proud that millions of our customers' set-top box X1 experience runs on OpenStack today. So that's pretty impressive for us. We also run our residential email services and product development. So, tens of millions of users and their mailboxes, terabytes of data runs on our OpenStack environment as well. And it's also a real critical part of our product development. It's how we are able to innovate and delivering new applications for our customers. We've developed hundreds of applications on OpenStack. It is a critical part of our many CI/CD pipelines, and it's really accelerating innovation at Comcast. And after listening to today's talks, I felt really compelled to be a cool kid and put some Kubernetes stuff on the screen too. If you're interested, that is a public GitHub repo that has a project that we did, which essentially leverages Kubernetes to deploy Yarn on top of OpenStack. So if you're interested in that, check out that repo. It'll get you started pretty quick. We also built a really big Hadoop cluster on OpenStack, leveraging Swift as the data lake and using things like SwiftFS and Cinder volumes as the HDFS environment. And so this was kind of the start of something that we started realizing, well, geez, this general purpose architected environment isn't going to work for all the major workloads that we're looking at today. And that's where we started seeing some complications and really the challenges. So here they are. This is kind of high level. I'll get into a little bit more detail. But these kind of new workloads, the Kafkas of the world, the larger Hadoops, were really straining the environment that we were putting them on. We weren't meeting requirements. We weren't meeting performance requirements. Functionally, the things would work, but we were missing a lot of capabilities. You go to, as a service provider to our internal customers at Comcast, we're constantly being challenged. Like, well, Amazon has this D2 or this I2 instance. Why can't you meet that as well? Well, we can, but it gets a little bit complicated, right? Because as we introduce these new environments, we also introduce complexity in operations, right? And we also add a lot of challenges in performance and scalability, right? So we have to transform our infrastructure. And one of the big things, and we just had Pure Storage up here talk about, is how do we meet our infrastructure to meet the storage demands of these modern workloads, Kafka, Hadoop, Spark, things like that. Well, the biggest challenge is like modern storage requirements demand provisioned IOPS, high I/O throughput, QoS, the ability to guarantee IOPS to an application, right, without having another application overtake or create noisy neighbor issues, right? And there's still the problem of that are being addressed, but of persistent container storage, right? We want to do Yarn on top of Kubernetes inside of OpenStack, but there's still the challenge of persistent container storage inside of OpenStack. Where does it come from, right? And so the demands of storage also create a ton of complexity, right? So noisy neighbors, there's a whole concept of, do we buy these converged nodes where we can get a lot of SSDs or a lot of HDDs on a single node and solve it with that, or do we solve it with disaggregated storage where we can maybe use a hybrid storage or an SSD array to kind of solve that problem? And in all of these challenges, I think one of the things that OpenStack does not provide very well today is operational awareness, right? In a lot of cases, if we see in a direct attached server in a hyperconverged node, we can't guarantee a QoS for any of the direct attached disks. And OpenStack doesn't really have the instrumentation to tell us that one workload is taking up more IOPS than another, right? And then there's cost. As a service provider, our customers are always coming to us and saying, look, we need more SSD, we need more performant IOPS, right? And Amazon can sell us SSD at 10 cents a gig a month. Why are you guys so expensive? Because we don't have the volume that Amazon does. We as big as a company as Comcast is, we don't have the kind of capability of Amazon-grade discounts, right? So the other thing that we telco providers have to think about is NFV, right? So in order to deliver virtual network functions, we have to meet these really complex requirements like high bandwidth I/O while exhibiting really low latency, right? We have to provide consistent and predictable CPU performance, and we have to be highly available, right? So these introduce a whole lot of challenges with multi-tenancy and operational complexity. And right now, SDNs, there's a tremendous amount of vendor reliance, and with vendor reliance, there's a tremendous amount of cost that's being introduced. As a cloud service provider, we've got to compare ourselves with other cloud providers in operational efficiency, right? So Amazon has a 3 nines SLA, and if they don't meet that SLA, they'll refund your 10%. We find it pretty challenging to do 3 nines inside of OpenStack today. I'm just being quite honest and transparent, right? So what do we think we need to create that operational efficiency? Well, a reference architecture would be interesting. We have a lot of large deployments, a lot of common, we have a lot of commonality with a lot of the other big infrastructure OpenStack users like the AT&Ts and Walmarts of the world. So it'd be interesting if we can, I don't know if it's a good idea, but if we can come up with a common reference architecture or even a common way of deploying OpenStack. If you listen today, we've talked about things like Cola and Stackernetes and Cola with Kubernetes, and there's OOO that Red Hat supports. There's the work we've done in OSA, OpenStack Ansible. There's like 15 different ways to deploy OpenStack, right? And it makes it very complicated. We apply a lot of effort into one and then realize that very quickly another one's superseding the one we've applied a lot of effort on. So it's kind of a challenging area to be in. And then we need a consistent upgrade path and backwards compatibility for APIs and things like that. Obviously, we need a consistent upgrade path. We're in Icehouse. And we need better visibility into the full stack to understand issues so that we can make better operational decisions. The same way we're doing big data on our networks to understand where there's faults, where there's, we're getting real-time data. We're building these applications on top of OpenStack so that we get real-time visibility into the network performance at your home, but we're not getting that out of OpenStack today. Right, so I'm going to skip through here. So although we continue to see year after year of growth in our Comcast Elastic Cloud service, and that demand has really been impacted by the increase in our ability to attain and retain, data, right? And they're really testing the limits of our networking capabilities. So our new Mitaka deployments are going to include a complete different network topology, a lot of, and I won't get into the details. So how do we solve this problem? And this is interesting because at the time when I put this together, and we had the idea of collaborating with large-scale operators, and it's kind of coming into fruition today. As of a couple of weeks ago, we've started a large, well, I'll say AT&T has helped start the large contributor OpenStack operators working group. It's not an official OpenStack working group yet, but it's comprised of some of the big guys, Walmart, AT&T, Comcast, Orange. And the reason we're doing that is because we have very similar technical debt at our level, right, at our scale. And we think it's important that, we're running into the scale issues that I think a lot of the smaller OpenStack operators are not going to see quite as often as we do. And if we think we can focus our efforts into solving those technical problems and providing the visibility into operations in OpenStack, we think we can really help the community. So that's the goal. We're going to put together a roadmap and then try to collaborate so that we can really focus on some of the issues that we think OpenStack is going to need and upstream it back to the community. And the last bullet is we have to embrace this chaotic environment, right? There's, we're going to have storage vendors for disaggregated storage. We're going to have converged nodes. We're going to have everything for now. And that's just the way that we think the problem's going to be solved. And that's the last slide I had. And sorry I ran through it really quick, but I'm really hungry.